reciprocal identities, anytime I see a cosecant, I want you to think of the cosecant as just being 1 over sine. That's what it is. It's a reciprocal of sine. Whenever you see a secant, it's really just a 1 over cosine. Whenever I see secant, I'm just going to convert it to 1 over cosine. Whenever I see cotangent, I'm going to think of it as being 1 over tan. But more importantly, here is the one that you should really think of it as, this guy right here. Think of it not just as 1 over tan, which it is, but think of it as a reciprocal of tan. And tan is normally sine over x. So cotangent is really cosine over sine x. So sine of x over cosine of x is what tan is. Every time I see a tan, I'm going to turn it into sine of x over cosine of x. We did this yesterday when, in fact, I went over it a few minutes ago. We did this when we were talking about find the tan of pi over 12. We turned it into the sine of pi over 12 over the cosine of pi over 12. And that's what this is saying. That tan is the same as sine over cosine. And cotangent is really just the reciprocal of that, cosine over sine. Another very important identity which you should have learned, and I know some people are saying that things kind of got shortchanged for you when you were doing the trig course last year during the pandemic. So we'll take that into consideration as we go through. So one of the identities you should have learned, and let's see if this sounds familiar to you, is this one here. It's called the Pythagorean identity. I'm going to underline it in red just to show you how important it is. That the sine squared x plus the cos squared x is equal to 1. When you add those two together, cos squared not equal to cos of, no, it's not. It is not. Carry's not really my values working today. All right, so you're looking at the cos of x squared, and it's not the same thing as cos squared x. Something we talked about yesterday, remember, Jeremy, that sine squared x means sine squared, it means sine of x times the sine of x. That's different from sine of x squared, okay? All right, good. So that Pythagorean identity comes up quite a bit in our work with trig identities. So you have to be able to recognize it. It doesn't always sort of put itself there and say, here I am waiting for you to identify me. But sometimes you just have to figure it out. Kayla, please go ahead. Okay, great. So you kind of have to be very alert and spot it when it comes up. But you see that quite a bit in these identities. But sine squared x plus cos squared x is equal to 1. I don't want you to focus too much on the next two. So I'm actually going to put a line through them, right? I'm going to say we can easily derive them, but I don't think we use them that much. The other ones that we use are really just this one rewritten in another way. If you were to rearrange the sine squared x plus cos squared x, put the cos squared x on the other side, you'd get this. That sine squared x is equal to 1 minus cos squared x. And if you did the other way around by putting the cos squared x as the subject of the equation, you get 1 minus sine squared x. These come up quite a bit when we're doing our identities. So these are not new. These are just rewriting the original one in a different way. That's all this is. All right? All right. Now, I'm going to ignore these cofunction identities, although we did do these, what, 2 days ago or 2 school days ago, right? So all of these things here, right? We're supposed to, I should be able to shoot any of these at you and say, what is, for instance, the tan of 3 pi over 2 minus x, right? And you should be able to say, oh, it's cot x. And that's because tan and cot are cofunctions of each other. Or what is the tan of 3 pi over 2 plus x? It's equal to minus cot x because I'm in the fourth quadrant. That kind of thing I'm going to be expecting you to be able to do. So let's now move on to how I do trig identities, right? You've not probably done trig identities the way I have done them before. Because most times trig identities are presented to you as this thing is equal to that thing. Left-hand side equals right-hand side. And you have to make a decision. Do I start with the left-hand side and make it eventually equal to the right-hand side? Or do I start with the right-hand side and make it equal to the left-hand side? Well, that's not Kamak style, right? What I refer to as Kamak style is I give you an expression, a trigonometric expression, and I say to you, take this expression and simplify it. I'll give you a commitment that once you've simplified it, it will only be one trig ratio. So it will either be sine, cosine, tangent, secant, cosecant, cotangent. It could be something squared. It could be tangent squared. It could be cotangent of 2x. It could be any of those things. It's never going to be sine plus tangent, or it's never going to be sine times cosine or anything like that. It's always going to be one ratio at the end. So whether that ratio is sine, cosine, tangent, secant, cosecant, or cotangent, it will only be one ratio. So when I give you that commitment, that tells you that when you are really finished this, Jeremy, I'm going to get to you in a minute. When you are finished this, right, the way you know that you probably got it right is when it has simplified to one trig ratio. Jeremy, go ahead, please. All right. I remind you that this is being taped, so you can always go back and look at the video later on, but I'll do that for a few seconds for you. But the video is a great way to sort of keep track of these things. Okay, so here comes your first example of how this works Kamuk style. I have secant on top, I have tangent on the bottom. Okay. We said from the very first page that secant is the same thing as 1 over cosine. So I'm going to write that down. That's what secant is. And then I also said that tangent was sine over cosine. So I'm going to write that as my denominator. Okay? Now, whenever you have a fraction over another fraction, which is what you have right now, the thing to do is to multiply the numerator by the reciprocal of the denominator. So I'm going to do exactly that. So this is equal to 1 over cosine of x times cosine of x over sine of x. So I'm multiplying by the reciprocal of that denominator. So here's my denominator, sine over cosine, and I'm taking it and flipping it over. I'm multiplying it by the top, and this is where I am right now. Okay, so what do you think I'm going to do next when we get to this point? What do you think is my next step at this point? Okay, Jeremy, go ahead. Yeah. Okay. Yeah, I wouldn't call it cross multiplication, but cross cancellation, I guess, is good enough. So what we're left with, I know there's a tendency to just cross stuff out, but be very careful. Cancel the cos x. Thank you, Joel. And Rachel said the same thing as well. Very careful. You can only cross something out when it's part of a product, not part of a sum. And you see what I mean when we go through as a couple of these. So here's what I'm left with at this point. I have a 1 on top. I have a sine x on the bottom. You never leave it in that form because you ask yourself, well, what is 1 over sine x? Well, that would be cosecant x. And that would be your answer. That would be your answer. So the secant of x divided by the tan of x is equal to the cosecant of x. That's what I'm saying when I say at the end of it, you only have one ratio. You're not getting left side, right side. You're getting one side. You have to figure out what that would simplify to at the end of the day. And in this case, it simplifies to the cosecant of x. Okay? So there's a nice, hopefully fairly straightforward one to get us started, just to get our feet wet. They're not going to be as easy as that all the time, right? But that one is one to sort of get an idea, just to kind of see how this Kamuk style one works. That's not the way you see presented in most textbooks, certainly not in the textbook that you have, where they're going to give you the two sides and ask you to prove that they're identities. I don't do that. Wi-Fi cutout. Okay, Lisa. All right. I hope you're going to be able to stay with us. And again, it's being taped, so if for some reason you miss a part of it, then by all means, you can ask if you come back in and you have a question. You can also consult with the video. Okay, let's move on. So that was a nice warm-up one. Okay, here comes another one. Cosine of x plus sine of x times the tan of x. So I'm going to be consistent. I'm going to take that tan of x and turn it into what the tan of x is. So this is equal to cosine of x plus the sine of x times what I said it was, which is sine of x over cosine of x. That's what I said that tan was. So all I'm doing is turning my tan into a ratio of sine over cosine. And I'm multiplying these two things. Put this over 1, if that kind of helps you to see what the next step is. So what about cosecant x? What about it, Kayla? Cosecant x is 1 over the sine of x. Okay? So what's cosecant? Oh, what's cosecant x, you're asking? All right, well, let me take you back to the first page. Cosecant x is what I'm pointing to right here. It's 1 over sine x. Right? It's a reciprocal of sine x. So that's why when I ended up with 1 over sine x, I had to turn it into the cosecant of x. Okay. So what do you think I'm going to do next? All right. What do you think happens next? Let me get some thoughts from you on this. Okay. Yes, Jeremy, go ahead. Okay. So let's do that. So we're going to have cos x plus, well, what is, and then by the way, denominator is going to be cos x, right? Because it's cos x times 1, so the other is cos x. So what's sine x times sine x? How do we refer to that again? Does anybody remember how we refer to that? I'm multiplying two sine x's together, right? There's your sine squared x, absolutely. There's your sine squared x right there. Okay, that's good. Now, whenever you have, and thanks, Kristen, thanks, Emily, thanks, Shania. I love it, and Harish. I love it when people are participating. Don't get that enough, and Joel as well. And it's a lot of the same people who are doing that. And that's why I have to call people out from time to time. Because if you just sit there just sort of watching me, you're not learning as much as you could as if you're participating. Okay, so thanks, Kristen, Emily, Janaya, Harish, Joel, and people like Jeremy and people like those who are always participating. I really appreciate that. All right. So I'm going to give you a clue as to what's going to happen next. I'm going to go ahead and I'm going to put this over 1. You can put anything over 1, right? Because you divide by 1, you're not changing it. What am I suggesting to you is the next step in the process? Cancel out the cos x. No, we can't do that, Janaya. No, you can't cancel it out. And that's the thing we have to be careful about. This is part of a sum, right? This is cos x over 1 plus sine squared x over cos x. Common denominator, Janaya. That's much better. Find that. Thank you, Joel. And thank you, Emily. We're going to find that common denominator. That's exactly what we're going to do. What would be a good common denominator between those two? So one denominator is 1, and one denominator is cos x. What would be, okay, good, good. I see that, and I see Jeremiah has his hand up, and I'm going to suggest that Jeremiah probably was going to tell us that it's cos x is the common denominator. Many times the common denominator is just multiplying the two denominators together. So the two denominators are 1 and cos x. So that would mean that cos x would be a good because cos x times 1 is just cos x. So I'm going to go through the process now. What do I multiply this by to get cos x? Well, it's cos x. So it's cos x times cos x, which again is cos squared x. Plus, what do I multiply the cos x by to get the cos x? Well, it's 1. So it's 1 times sine squared x. So sine squared x. Okay? All right. Does anybody notice anything that can help us out with what you see right now? Okay, Joel, go. What do you think? And Noah has his hand up as well. Divide? Not yet. Noah, you had your hand up as well. And Jeremiah as well. Noah, go ahead. Ah, nice, nice. So what you're noticing is that this is that Pythagorean identity we talked about, cos squared x plus sine squared x, which is in fact 1 over the cos x. And yes, what Noah also said is right. That's the same thing as secant x. Never leave it in the form of 1 over cos x. If you're looking for full marks, that is. If you're not looking for full marks, then yeah, you can leave it like that. But if you want full marks, you got to go all the way here. So it's secant x. And then you can say to yourself, well, that's just one ratio. Mr. Kamal said that if I ended up with one ratio, it's probably right. All right. And so secant x is, in fact, that one ratio that really simplifies all of this. So this here is really the same thing as secant of x. That's it. That's it. Okay, I think we're kind of getting the hang of it. And it is going to get more challenging as we go along. I should tell you that, but so far I like it. I like the kind of input I'm getting from the class. Okay, we're going to do what we've always said we're going to do when we have tan x and cotangent of x. Okay? We're going to say cosine of x. We're just going to repeat that. We can't change that for right now. I'm going to change tan of x into what we said the tan of x is, which is sine of x over cosine of x. And cot of x is what we said that the cot of x is, which is the reciprocal of this. So cos of x over the sine of x. Okay? Paul Pass Omar says, and Nicholas says he's joining now. Okay. All right, so Nicholas, let me quickly fix my attendance. Where is Nicholas? Nicholas. Where's Nicholas? Oh, here he is. Okay. All right, so let me just go over the people I'm missing yet again. Still missing at this point, Rylin and Keontae. So if any of those people have joined, you need to let me know. The minute you come in late, you need to let me know. This makes the homework much harder. Okay, good. All right, and by the way, hopefully Omar can hear this. Omar, expect you back within 5 minutes. All right. Okay, so let's keep going here. What do you think I'm going to do next? What do you think I'm going to do next? Any thoughts on, sorry to repeat, but Keontae is in the, yeah, but if I'm not hearing from Keontae, then I'm going to have to mark her as being absent. Sorry, Keontae needs to respond when I call out. And if I don't hear from Keontae, it means that she's not really present in class as far as I'm concerned. Okay? All right, so let's keep going here. What do you think I'm going to, oh, common denominator. Thank you, Harish. Thank you, Harish. And what do you think is a good common denominator for that fraction? So I have a fraction which has a denominator of cos x and one has a denominator of sin x. What would be a good common denominator? Yes, Jeremiah, go ahead. The sin x times cos x. Good. Okay, so let's go ahead and do that. Just take the product of those two. So I'm put my common denominator as cos x times sine x. That's my common denominator. The dot there, of course, means that I'm multiplying. So let's go through the process again. What do I multiply cos x by to get this? It's going to be sine x. So it's sine x times sine x, which is sine squared x. We've talked about that before. What do I multiply sine x by to get cos x sine x? It would be cos x. So it's cos x times cos x. So it's cos squared x. And again, we've seen this before. We know that sine x plus cos squared x is just simply 1. So I'm going to go ahead and rewrite this as the cos of x 1 over cos of x dot sine of x. Okay? All right. Okay. Well, how about if I put this over 1? Anything can put over 1. Does that suggest anything that we can do with this at this point? Right? Cos of x on over 1. Cancel what, Noah? What are you talking about? Which one can we cancel? Cancel the cos x's. Good. So I can cancel out this with this. It's part of a product. It wasn't cos x plus sine x. If it was cos x plus sine x, I could not do that. But it's cos x times sine x. And that's just cos x, so those do cancel. Noah, go ahead, please. Yeah, that's actually a good idea. Yes. So if I understand what Noah is saying, he's saying that when I multiply cos x times 1, it ends up being this. Cos x over cos x dot sine x. And then it's probably more obvious what's left behind, that the cos x's will in fact cancel out. So what am I left with, folks? That's the big question. What's at the end of this thing here? Then you'd turn it into cosecant x. Well, first of all, it would be 1 over the sine of x. Let's start with that first, right? Some people forget that 1 is on top. And that, yes, is equal to the cosecant of x. Okay? 1 over sine x is in fact the cosecant of x. So what that says is that this thing up here, this big complicated thing, cos x bracket tan x plus cot x, is really just cosecant x in disguise. That's all we're saying. And that's all it works out to. Okay, so far we're doing well. So far we're doing really well. Haven't heard from a couple of people though, which I am hoping we will change. You know, Riddy, Sharisa, Shiabon, excuse me, people like that. Hear from Noah all the time. You know, don't hear from Omar. You know, yeah, I do hear from Travis once in a while. Yeah, that's true. Joel, I hear from, but a lot of people I don't hear from. So let's see if we can get a little bit more participation going here. All right. Okay, next question is this one here. Ooh, okay. Ouch. When did we get to 2x? What do we do with that? All right, let me remind you what cosecant is to start this off. Let me remind you what cotangent is to start this off. So I'm going to start off by saying that cosecant is 1 over sine of 2x plus cotangent of x is the same thing as the cosine of 2x over the sine of 2x. Notice that it's 2x because the original thing was a 2x. So if it's a cotangent of this, then it's the cosine of that over the sine of that same thing. Okay? What is SIW? What does SI? Oh, it's not SIW, it's SIN. It's my horrible, horrible, horrible writing. So let me fix that. Does that look a little better now? Okay, all right. SIN. So, and that's a reason. Yeah, it still doesn't look good. Hold on. Let me try that one more time. That's better. Okay, well, that didn't really do very much for us. Except, I just noticed something. Does anybody notice anything there? Isn't cotangent 1 over tan? It is, Joel. And what is tan? Let's go through this. What's tan? What's another way to write tan? Give me what another way is to write tan. With very first page, we talk about what tan really is. Okay, what's the reciprocal of that? Jeremiah just put it sine over cosine. What's the reciprocal of that? Because since cotangent is 1 over tan, yeah, 1 over tan. Okay, so since tan is sine over cosine, and since cotangent is 1 over that, should we put it the other way around, cosine over sine then? There you go. Does that make sense? Just want to make sure that Joel is okay with that before I go any further. Joel, are you good with that? Okay, good. All right. So does anybody notice anything here that might be of any use to us? You know, you gotta sort of be sharp sometimes and notice same denominator. Ah, that's a very good observation there, Harish. That's an excellent observation. Why is 2x in both the numerator and denominator? Janaya asked. Because it started off being the cotangent of 2x. So if it's a cotangent of 2x, Janai, it means that when you are rewriting it in any other form, it's still going to be 2x. So if I'm writing it as cosine over sine, it has to be the cosine of 2x over the sine of 2x. Okay, Janaya? Make sense? I just want to check in with you on that. Does that sound about right to you? It can't be 2x over x. It has to be 2x over 2x because it was originally a cotangent of 2x. Now, some of you have very astutely recognized that they have the same, that was Harish, they have the same denominator. So I can just add them up right now. And I can say the following. Sine 2x is my denominator. And on top, I'm going to have 1 plus cos 2x. Absolutely can do that. Does that make sense so far? All right? That 1 plus the cos 2x is what you would have if you were to have the same denominator of sine of 2x. Okay. What now? Does anybody have any other ideas as to where else we can go? I'm just going to wait to see if anybody has anything before I go any further. Could you cancel out the 2x's? No, you cannot. Because they're part, first of all, part of a sum. Plus, it's not like you're saying cosine times 2x and sine times 2x. It's the cosine of 2x and the sine of 2x. So you can't do that. Looks like something we can use, but I would have to square it somehow. Pythagorean. What do you mean by Pythagorean? Cosine of, I don't see how the Pythagorean theorem would, or Pythagorean identities, I should say, could come in yet. It may, but not yet. Not yet. Cotangent is, okay, yeah, we got that. That's where we got that cosine of a sine from. Okay. But let me ask you this. Do we have an identity for the cosine? Okay, Jeremy, go ahead. Let me hear what you got first before I say anything else. Go ahead, Jeremy. No? Okay. All right. Go look at your notes, everybody. Look at your notes right now. Did we have any identities for cosine 2x? Do you have any identities for sine 2x? Go look back at your notes. Okay, look at what Harish just wrote down. You see what Harish just wrote down? I like that. I'm going to replace the top of that with what Harish just said. So 1 plus, okay, Harish said that this cos 2x is the same thing as cos squared x minus sine squared x. Do we also have an identity for the bottom? Is there anything that we could use for sine 2x? Is there anything at all that anybody can think of for sine 2x? Do we have anything for that? Look at your notes, folks. There may be some. Okay, Axis says 2 sine. I'm going to write that down. 2 sine x dot cos x. All right, because I like that. I do like that. All right. But I still don't know what to do with this. Anybody have any thoughts on how we can simplify this some more? Look at the top. Is there any way I could rearrange the top and maybe Pythagorean identity? Tell me what you mean, Noah. Give me some more details on that. The Pythagorean identity, how did you get that, Janaya said? How did I get what part? Mm-hmm. 1 plus cos squared x, this first part here. You say these two together is sine squared x. Is that what you're saying, Noah? And Jen, I'm going to answer your question in a minute. Right. How about if I did this? How about if I did this? And by the way, Jenna, you said, how did we get that? What part are you talking about? Let me just answer Jenna's question first. What part are you not sure about? The denominator. You need to go and look at your what we did yesterday with those compound angle formulas. We developed an identity for sine 2x. And it worked out to be 2 sine x cos x. It's just one of those identities from, and it's on the first page, by the way. I'll go back to the first page for a second here. On the first page, it's not here. Oh, darn. That's okay. So it's not here. I thought I had it on the first page. Anyway, from yesterday, if you go back and look at yesterday's work, we did have an identity for sine of 2x, and it worked out to be this. So just try and find that, Jana. It's there. It's not something that would necessarily occur to you right away, but there is one. Think of it. Think about the fact that there is one for sine 2x. There is one for cos 2x. Okay? All right. Jeremy seems to have an idea. Go ahead, Jeremy. Okay, let me try this then. Let's just, we can write things in a different order, right? Could you simplify cos squared x to sine squared x times cos x and sec to sine? Okay, that's an interesting idea. I like those ideas. But how about if I did this? Is it wrong for me to write this, the top line of this, a different way, to say 1 minus sine squared x plus cos squared x? Would that be wrong if I did that? Or is that okay? What do you think? And if you say yes to that, why do you think I did that? I changed the order in which I wrote them down. No, don't be careful. I know some of you are going to think, oh, here's a sine squared x and a cos squared x. Why don't we just call those one? That's not true. This is minus sine squared x plus cos squared x. So that's not what we're talking about, right? But there is something there that some of you might notice. Yes, Jeremiah? It could be. It could be. But how about this? Yeah, you're right. But look at this. I'm going to circle something and ask you to think about that for a minute. Did we see this somewhere? Does that look like something we might have seen somewhere? Look back at your notes. You said you had a screenshot of the first page. Oh, look at what Harish just said. Look at what Harish just said. Jeremiah, what did you want to say? Sorry, say it again. Okay, so it sounds like, and I'll take it back to the first page, because one of the identities that we talked about was this, that cos squared x is equal to 1 minus sine squared x. I'm pointing to it right now. So if I have 1 minus sine squared x, that's cos squared x. So I'm going to replace that 1 minus sine squared x, the thing in the circle, in the red circle, I'm going to now call that cos squared x. So that's cos squared x plus another cos squared x all over 2 sine x dot cos x. Okay, so what do you think is next, folks? Again, I'm turning it over to you. Do you see any options here? Do you see anything we can do here? Do you have any ideas? All right, I have a cos squared x, another cos squared x on top. It's over 2 sine x cos x. Jeremy, what do you want to tell us? I see what Rachel has. I see what Joel has. Jeremy, is that what you had in mind? You can say yes or no to that if that's what you had in mind. Okay, so let's do that. Let's put those two together. I must tell you, right? I'm going to be a little bit personal here. I used to love these things when I was sitting where you're sitting right now, right? That probably makes me a geek, but I'll take the label. That's okay. Anyway, so this is equal to 2 cos squared x over 2 sine x dot cos x. Okay? All right. Okay. Looks like we're a little bit closer to coming up with something here. What do you think could be next? So it's 2 times cos. Remember, cos squared x is the same thing as cos x times cos x. Couldn't you just cancel cos squared x and 2 cos x from the denominator? Sort of, Harish, unless I want to be careful now. Can we all agree that twos will cancel? Can we all agree on that first of all? Can we all say that the twos will cancel? Can I get some agreement on that first of all? Yes, no, nobody sees that as really says yes. Carissa, perfect. Okay, so let's just cancel those twos out. It's all being multiplied. No, what I'm left with is cos squared x over sine x cos x. No, this is like saying cos times cos on top. So wouldn't that mean that one of those causes on top, cos squared causes on top, gets cancelled out, so I'm left with only one cos x on top. And then on the bottom, I would cancel out one of those causes on the bottom, leaving me with just simply sine of x. Does that make sense? What I just wrote down, does that make sense? Right? I have cos x on top, one left, right? Because it was a cos squared, but it cancels out with one of the causes on the bottom. and then I'm left with just one cos on top, and I still have that sine x on the bottom, right? How does that sit with, okay, so I'm getting some agreement on that. Is everybody else in the class seeing that? Which would equal, yeah, we're going to get to that, Kayla. We're going to get to that, right? And as I always said, it's never going to be two things. It's always going to be one thing. So yes, you need to go a little further than that. But this cos x over sine x, which as Kayla has rightly pointed out, is equal to the cotangent of x. That's my final answer. That is the one ratio, Carrie says it, and Kayla had brought that up before, is really what my final answer is, cotangent of x. One ratio. It all boils down to one thing. And that's my commitment to you. I mean, I'm not going to say that any random trigonometric expression is all going to boil down, but the ones that I've chosen to give you, that I call the Kamak style trig identities, always boil down to one ratio at the end. All right. Now it could be 2 cot x or cot squared x, or it could be all kinds of different ways of expressing the cotangent, but it is still only one ratio. And that's the ratio cotangent of x. Okay. See how interesting these can be? So here's what we started off with. We started off with cosecant 2x plus cot 2x. Turns out it's really just cot x in disguise is really all it is. That's really all it is. Whew. Okay, let's see if we can get through one more before the break, and then we'll take our break. Okay then. Wow. I'm looking at this and thinking, that was a quantum leap there, Mr. Kamak. You just kind of went from baby steps to a full-blown Usain Bolt sprint. What am I supposed to do with this thing? All right. Any first thoughts? Anything anybody notice? I'll give you a one-word clue in a second, but does anybody see anything that we can do with this apart from running and hiding? Your brain just exploded. Yeah, right. All right. We'll try to avoid any medical mishaps here. Cancel the cos 2 out. I don't, but I don't see a cos 2x in the bottom though, so I don't know that I can do that, Karis. Cancel out what, Rachel? Tell me what you're thinking we can cancel. Because I don't see an opportunity for canceling yet. I hope you're not thinking we can cancel maybe the cos x with the cos x, because I can't do that. No. Remember, if it's part of a difference, which it is, top is part of a difference, the bottom is part of a sum. So I can't just take a piece of a sum or a piece of a difference and cancel it out. So no, that doesn't work. All right, so let me give you a little bit of a clue here, unless anybody thinks they've got anything. Okay, Jeremy, go ahead. Ah, yeah, that might be useful. And let me just say this to you, not just Jeremy, but the whole class, is that you need to think of different things that you can do, because there isn't one route. As I keep saying to you in math, there may be more than one way to get to your final destination. And what Jeremy just said may work or may not work. I just told you I get a lot of pleasure from doing these things. Yes, I know that makes me strange, but so be it. And I've tried things that ended up in a dead end. So sometimes you're going to try stuff like what Jeremy just said that may not lead anywhere, but it's at least a good start, because it may lead somewhere and you don't know that it will or it won't. Try it. That's what I'm going to say to you. Try it. Pythagorean identity for cos squared x. Okay, Joel, remember that the Pythagorean identity is cos squared x plus sine squared x, but this is cos squared x minus sine squared x. So this wouldn't be the Pythagorean identity on this one. Okay, just wanted to point that out. All right, here's my clue to you. One of the things I'm always saying to you is that if you have any fractions, find a common denominator, put them together. If you have anything like a tan or a cotangent, change it into what those things are. Change tan into sine of a cos and cot into cos of a sine. Secants and cosecants, change them to 1 over, change all those things. Here's another thing that you should be looking for when you're doing these identities. Opportunities to factor. Because if you can factor, eventually you may have common factors which you can cancel out. So I want you to think about that for a second. Are there opportunities for factoring any of what you're looking at right now? Can anything be factored here? Anything at all? Jeremy? So you're saying it's a difference of squares, which it is. I like that idea. How about the denominator? Can that be factored as well? Okay, let's try that. Let's try that. Let's see if that leads us anywhere. And by the way, I'm not dismissing your idea from the first part of that, Jeremy, where you talked about changing the cos squared x minus sin into cos 2x. That's something that's worth exploring, right? But let's just try what you just said as an alternative. So this is equal to 1 minus, the numerator is going to be a factor or factors based on this being a difference of squares. So cos x minus sine x in one bracket, and cos x plus sine x in the other bracket. All right, let me see if I can bring this over some more. It's a little bit kind of squeeze up on the end there. Okay. You also mentioned the bottom was factorable because there's a common factor of a cos x there. So cos x would give me cos x plus sine x. Can we all agree on that before I go any further? Does that denominator that I just factored make sense to you? Cos x into cos x plus sine x. Okay, if you can see that, does that denominator make sense to you? Just want to be sure that that makes sense before I go any further. Perfect. Good, really. Thank you, Archana. Thank you, Ava. All right. Where do you think I'm going to go next then? Where do you think it makes sense for us to go next? Now that I've factored them, I said to you, factoring gives you the opportunity to cancel, right? You couldn't just cancel out. What can we cancel out, Jeremy? Exactly what can we cancel out? Which is what Karis just said. Yes, and exactly what Karis just said, and exactly, not just the cos x really, but the cos x plus sin x, the whole thing. You can't just cancel out the cos x on its own, but you can take this with that. That's what we're saying we can cancel out. So here's what we have left, and then we'll take our break. What's left after all of this is this. 1 minus, so we still have cos x minus sine x on top over cos x. That's where we're at. And by the way, do not get tempted. I cannot cancel out this cos x here with this cos x here because this is part of a difference. I want to stress that. I keep saying that. Now, I want you to be careful. See that minus that you have in front of this fraction? Think of that minus as applying to everything on top. That's how I usually like to think of it. When I have a fraction and a minus in front of the fraction, I think of that minus as applying to everything on top. So that's like saying minus cosine of x plus sine of x. Think of it that way as we go through this. It's like multiplying this whole thing by -1, the top, not the bottom, just the top. Just think of it that way. Okay, so where do you think we're going to go next? Now that we're back on track and everybody is back with us, common denominator, Rachel says, I like it, Rachel. I like it. So let's do that. Cosine of x is a common denominator, right? Hopefully everybody saw that. By the way, this is 1 over 1. So that means the common denominator would be the cosine of x. So let's just think this through now. It's what do I multiply this by, this 1 by, that gives me the cosine of x, cosine of x. So it's going to be cosine of x. And then what do I multiply this by that gives me this? It's 1. So it's going to be, remember what I said to you earlier on? Think of this as being minus the cosine of x plus the sine of x. right? Because what you're doing is you're minusing everything that was on top. So it's minus cosine of x plus the sine of x. Does that step make sense to everybody before I go any further? That is minus cosine of x plus the sine of x. Okay, Kara says yes. What about everybody else? Ava says yes. Some of the usual people who chime in, good, good. Janaya says yes, good. Keontae, excellent, excellent. Okay, so obviously we can simplify that to give us just the sine of x. And of course, that's over the cosine of x. That was what was there before. And everybody knows we're not going to leave it like that, because that's not good enough. We're going to call this the tan of x, of course. There's my commitment to you again. Never is it going to be more than one ratio. Sine over cos is just simply tan. Cos of x minus cos of x, of course, is 0. So I left to just the sine of x. So sine of x over cos of x is tan of x. Now, is there another way to do this? Of course there could be. But that's just one way that I found that works well. And if anybody comes up with another way, I'd love to hear it. I'd love to hear it. What Jeremy said before about this being the same thing as the cos of 2x, yeah, that's true. And maybe there's something there that we could work through to actually end up with the same answer, but it's always going to end up being this, just so you know, right? Doesn't matter how you do this, you will never get a different answer than this answer right here. It's always going to be the tan of x at the end. Always, always, always. And that's the beauty of math. Different strategies, different routes, same destination at the end of the day. Okay. You can tell I love this subject. I know you can. Let's see what we can do with this one. Now, this is by far the most challenging one. I'm not going to lie to you. This one is the one that's going to take more time and probably require more explanation than any other one. It's the last one that we're going to be going through as a class. But let's just sink our teeth into it and do our best. All right. So 2 cos sine 2x minus sine cos 2x over sine 2x. All right. Tell me anything you think we should try. I mean, even if it doesn't end up being the best way to go about it, just tell me anything you think you might want to try, and we'll try it. We'll consider it, and maybe it might take us in the right direction. Maybe it might not. But let's just hear what you got. Distribute the property. So you're saying multiply that 2 into the bracket. Janaya is thinking. All right, Janaya. Okay, fair enough. And we could do that. We could do that. But the reason that I'm probably not going to do that is because I see an opportunity right now where we might be able to cancel out that 2. So rather than it becoming something that is going to make our lives a little bit more challenging, I'm thinking if I cancel it out now, first, no, I get that. And Janai, that's what I'm looking for. That's exactly what I'm looking for. Ideas. Exploded again. The same brain just keeps exploding. All right, that's interesting. So anyway, here's okay, Jeremy. What do you want to tell us? That would be a good idea. And I think the place I want to start off with that, Jeremy, I want to run with that idea for a bit. Look at the denominator, and is there an identity for that? Let's see the numerator identities for now. But how about that denominator? Is there an identity for that? Because that might actually be useful. You'll see in a second why I'm saying that. Can anybody find the identity for sine of 2x and tell me what that is? You can put it in the chat. What's the, and we just used it a few minutes ago. The identity for the sine of 2x. 2 cos x, absolutely. That's going to be my starting point. I'm going to leave this as being this. So cos x sine 2x minus sine, I don't know, I'm using cursive and let me be consistent here. Let's go all cursive on this. Minus sine x dot cos 2x on top. But I'm going to change the bottom into 2 And I went back to, anyway, 2 sine x cos x. This is bad. I'm mixing cursive and script at the same time. Now, why might that be helpful? Why might that be helpful? Is there any opportunity to simplify right away that you see, that anybody sees? Yes, Jeremy? Absolutely. That means we wouldn't have that to bother about anymore. So what I'm left with is, let me see if I can be consistent now. I'm left with cos x dot not being consistent, sine 2x minus sine, I don't know why I'm not being so inconsistent, minus sine x dot cos 2x all over just simply sine x dot cos x. Okay. Now, it may not be a bad idea for us now, because I don't see anything else that we can factor right away. I really don't. It may not be a bad idea for us to now bring in some of those things that we just talked about, which is kind of what Jeremy was just saying. Wherever I see cos 2x, I might want to bring in the identity for that. Wherever I see sine 2x, I might want to bring in the identity for that. So let's start off with the sine 2x. Let's start off with that. So that would give me cos x times, what is sine 2x again? What do we say sine 2x was again? I would just, in fact, Harish has it in the chat. I'm just going to use what Harish says. 2 times sine x dot cos x. And then I'm going to minus from that sine x. I'm going to leave it as cos 2x for now. And you'll see why I'm doing that in a minute. I want to do this in stages. Excuse me 1 second, please. Sorry, I'm back with you now. And I'm going to leave that as being cos 2x for now. You see why I'm doing that. I just want to do one thing at a time. And I'm all putting that over the sine x dot cos x. I keep mixing cursive with script. Sorry. Maybe I'll just go all script after this. Now, why might that be of some usefulness? Right? Does anybody, actually, let me just take off this thing on the end here. I don't need this other bracket here at all. Oops, sorry. Let me just take this thing off here. Okay. Okay, we can cancel sine x, Jeremy is saying. No, we can't, because that's part of a difference. We can't cancel, but we can factor. Yes, we can factor. What exactly can we factor at this point? All right? Jeremy is right about the factoring, but Jeremy, not Jeremy this time. What can we factor? Look at the top. Is there some common factor on the top that anybody notices? All right. Does anybody see any common factor on the top? Jeremy has said it, but I want somebody else to tell me what is that common factor on top. Right. Look at all of the terms I have here. I have cos x times 2 times sine x times cos x minus sine x times cos 2x. What's the common factor? Sine x cos x? Not so much, because one of them is cos 2x. But I would agree with you, Rachel, if you said the sine of x was a common factor. I would agree with that. Okay, so I'm going to factor out that. I'm also going to say that this cos x and this cos x could really be cos squared x. Could we call that cos squared x? This thing here, which is a cos x, and that thing there, which is a cos x, we could call that cos squared x. But I can also cancel out that sine x. You're right about that. So let's cancel out, not cancel out, let's factor out that sine x. So sine x, sorry. So sine x, I'm going to put 2 cos squared x, right? Because I factored the sine x out of this part here, minus cos 2x. all over sine x dot cos x. I just have this temptation to use cursive and script at the same time, and I'm trying to resist that temptation. All right, okay, let's try that again. Sine x times cos x. Okay, so all I've done is I've factored out the sine x out of this, and by the way, I've combined the 2 with the cos x and the cos x. Those two cos x become cos squared x, and I'm still minusing cos 2x. Remember, I factored out the sine x, so this sine x is no longer there, and this is what is left here now. Does that make sense, everybody, what I just wrote there? Just want to be sure. Right, if I multiply this back out, the sine x into this and the sine x into that, I'd end up back with what I started off with on the first line. So let me just do a quick survey of the room. I'm not asking you for the next line, just asking whether that made sense. Kristen, how about you? Does that make sense, or do I need to go with that again? Kristen, what do you say to that? That line I just put in. So you're good. Okay. And let me hear from Nicholas on that. Nicholas, does that make sense? Are you good with that, what I just wrote down? Where's Nicholas? Where's Nicholas? Could you go over it again? I sure can, Nicholas. I sure can. Okay. Look at these two terms that are being subtracted from each other. Can we agree there's a common factor between them, Nicholas? Let's start with that. That the common factor there is a common factor between them. Can you see what that common factor is between both of these terms that I'm pointing to here? Tell me what the common factor is. What is the common factor? What is the thing I can divide into both of them? The cos x? No, because this is cos 2x. It's not the same thing as cos x. So what else do you see that's common to both of the first term? This is cos times 2 times sine times cos. That's what this is. This is sine times cos 2x. So what's the common factor there? What do you see that both of those terms have? The 2? No, I don't see a common 2 at all. This is cos of 2x. And this 2 here is not part of this. This is 2 times sine x and 2 times cos x. So it's not like this is sine of 2x or anything like that. Look at these 3 terms. Look at these 2 terms. There's something else that's common to them. I'm not just asking Nicholas, by the way, right? I'm asking the whole class. What is that common factor between both of those 2 sets of terms that are being subtracted from each other? What is common to them both? Thank you, Kayla. The sine of x. Do you see that, Nicholas? The sine of x is common to both of them. I want to be sure you can see that before I go any further. Let me know. Okay. So all I've done, Nicholas, is I have divided this first part of it by the sine, because I'm going to be factoring out the sine of x. So anything we're factoring out, we're dividing out of this and dividing out of this. So if I divide the sine x out of this, I'm going to end with cos x times 2 times cos x. Well, I just call that 2 cos squared x. That's what I call it, right? But that's what's left behind. Cos x times 2 times cos x. Cos x times cos x is cos squared x, and there's a 2 as well, so it's 2 cos squared x is what I'm saying. Let me check with you on that. Does that part make sense? Okay, good. And then I divided this by sine x as well. I'm just left with cos 2x. Now, I can reduce this here. Does everybody see how I can reduce this? I have a sine x on top times this. I have a sine x times a cos x on the bottom. So it's okay for me under those circumstances to cancel this out. Okay? So here's what I'm left with so far. I'm now left with 2 cos squared x minus cos 2x all over just simply cos x. All right? And it's okay for you to say, I still don't get that. And I can go over that again. And I can go with a little different way of doing it to make sure that everybody follows what I'm doing. I'm okay with that. All right? All right. Don't get that? Okay. Thank you, Janaya. All right? And I appreciate all the Janayas in the room. And when I pluralize it, I'm meaning all people like Janaya who will say, can we do that again? Right? That's what I want if something didn't quite stick. So I am saying that first of all, did the factoring part of it make sense? Did that factoring make sense? Did the sin x into this make sense? Let's start with that first. Is that good? Or do I need to go back through that again? Not totally. All right, let's do a quick factoring review here. Let's just say, I'm just going to make something up here, that I had 5x squared y minus 2y. All right, let's just use that as an example. What's my common factor here between those two things, Janaya? Tell me what the common factor is, the y. So I'm going to put the y here on the outside, which means I'm going to open the bracket and I'm going to really have to divide y into both of these. Isn't that the way that works? And then whatever I get, I'm going to put inside the bracket. Does that make sense, Janaya? So what would be left inside the bracket then? Tell me what's left inside the bracket when I divide both of those things by y. 5x squared minus 2. Agreed. Let's try. And so that would be the result of factoring that. Let's try one more. What about if I had 6x squared b cubed plus 3xb? Let's go with that. Right? First of all, what is my common factor this time? Can you help me with the common factor first, and then we'll go from there. So 3x, okay. So 3xb. So I'm going to bring this down a bit. Give myself some room. And aren't we therefore going to divide both of these by the 3xb? In that case, isn't that what we're going to do? So what's left inside the bracket after I do that then? What's going to be left? So 2x b squared. I think you got it right. Okay, no, hold on. Let me just think here. Oh, sorry, I'm dividing this by 3xb as well. All right. So 2xb squared. Yeah, you have 2x squared though. I don't know why I'd have x squared. Because x squared divided by the x would just give you 1x. Wouldn't that be true? 2x and then b squared. Yeah, and then plus what? That's okay, plus 1. In fact, actually I had before, plus 1. Good. Okay. So that's a quick little factoring review. So let's go back now and look at what we had before. I had cos 2 sine x cos x minus sine x times cos 2x. Can we agree that sine x is a common factor? Can we agree on that first? Okay, okay, all right. So just so you know, this thing here, which is looking very untidy, let me see if I can clean this up a bit. I think part of the problem is that my writing is so appalling. Yeah, I know. Anyway, I took the sine 2x, I made it into 2 sine x cos x. That's just one of those identities that we talked about. So that's where that came from. Let me start with that. So this thing here, sine 2x, if you go back and look at the identities that we looked at before, that was 2 sine x cos x. So just make sure you can find that somewhere so that that part, at least that part makes sense. Okay? All right. So what we're doing is multiplying these four things together. Cos x times 2 times sine x times cos x. So these four things are being multiplied together. Okay? On the second part, the part that's being subtracted, and let me clean that up as well. On the second part that's being subtracted, I have sine x times cos 2x. That's all it is. So isn't sine x a common factor between both of these? Would you agree with that? That sine x is the common factor. So I put the sine x on the outside. I'm going to divide this by sine x and divide that by sine x. So if I divide this by sine x, I'm going to be left with 2, the cos x, and the cos x. Well, I just call that cos squared x, because that's what cos squared x is. It's cos x times cos x. So because I have a cos x and another cos x being multiplied together, I call it 2 cos squared x. Sorry, I call it cos squared x, but then there's another 2 that was also there, which I put back there. And then I divided this also by the sine x, and that just left me with the cos 2x. Does that sound a little better now? Correct. Until I recognized that there was a sine x that was a common factor to the top and the bottom, which is why I just canceled them out a few minutes ago. Okay? All right, good. So all of that is over cos x, as we said. So here's where we are. All right, here's where we are. 2 cos squared x minus cos 2x over cos x. So maybe it's time for us now. This is why I did it in stages. Maybe it's time for us now to think about that cos 2x, which people were talking about from before. I didn't want to introduce it earlier because I didn't want to have too many things to be playing with. But we had an identity for the cos of 2x, didn't we? Does anyone remember what that was? The cos of 2x? Anybody remember what the cos of 2x is? Because I want to replace that cos of 2x with its identity. Can anybody find that identity and give that to me? Put it in the chat, or just you can just unmute and say what you think it is, the cos of 2x. Anybody? Nobody? It's one of the identities that we talked about, the cos of 2x. Nobody remember that one? All right, so I'll tell you what it is, since somebody remembers that one. Thank you, Noah. Thank you, Noah. So I'm going to write that down this way. So 2 cos squared x, which is what was there before, minus, but I put it in brackets because I'm minusing all of that. So as Noah just said, it's cos squared x minus sine squared x all over cos x. Okay? Now, I'm going to take away that bracket. Remember, I'm minusing everything. Everything is being minus, which means I'm minusing this and minusing this. So here's what I'm going to have. I'm going to have 2 cos squared x minus cos squared x plus sine squared x. All right? So minusing both of these all over cos x. So where do you think I might go next? Without me making any hints or comments, does anybody see anything that might be useful for us right now? Hello, class. Does anybody see anything at all that might work here? So 2 cos squared x minus cos squared x plus sine squared x. Subtract the cos squared x's. So it sounds like you're saying we could simplify this because I have a 2 cos squared x minus a cos squared x. That's just going to give me 1 cos squared x. So let's put that in. So that's going to be a cos squared x plus, of course, the sine squared x that was there over cos x. And I think everybody knows the next step. I think. What do you think my next step is going to be? Numerator is equal to 1. Thank you, Rachel. Thank you, Harish. Numerator is in fact equal to 1. So it's 1 over cos x. And yes, that of course is not left in that form. That's equal to secant x. So at the end of the day, this beast, this ugly looking thing here, this monstrosity, turned out to be a meek and mild secant x. That's all it is in disguise. It looks like it's bigger than it really is. Right? It's just secant x in disguise. Right? We tame this monster. This thing is no more than secant x in disguise, is really all it is.